Hello everyone, I am Ms. Mrinal, Assistant Professor at MERI College of Engineering and Technology. In this presentation, we are going to understand one of the most important and revolutionary concepts in today's digital world, public blockchain. I will also explain what public blockchains are, how they work, their key characteristics, real-world applications, advantages, etc. Before we talk about public blockchain, it is very important to recall what blockchain actually is. A blockchain is a decentralized and distributed digital ledger that records transactions. Let us break this definition into simple terms. Digital world means a record book stored in electronic form. Distributed means this record is not stored at one single location. Instead, it is copied and shared across many computers. Decentralized means there is no central authority like a bank or government controlling it. Each transaction recorded in blockchain is grouped into a block, and these blocks are connected together using cryptographic techniques, forming a chain of blocks. Hence, the name public blockchain. One of the most important features of blockchain is immutability, meaning once data is recorded, it cannot be changed or deleted. Blockchain also ensures transparency. Everyone in the network can verify transactions security. Data is protected using cryptography. Trust without intermediaries. There is no need for third-party verifications like bank or clearing houses. Now, a very important question arises: if blockchain is so powerful, why do we need different type of blockchains? The reason is that different organizations have different requirements. Some key reasons include: first one is addressing different business needs ranging from small startups to global enterprises. Small startups may prefer open and low-cost system, while large enterprises need more control, security, and customization. Second is balancing the trade-off between privacy versus transparency for sensitive data. Some applications require full transparency like cryptocurrencies, whereas others handle sensitive data and need privacy, such as healthcare or banking systems. Another important factor is permission versus permissionless access. In permissionless blockchains, anyone can join and participate, while permissioned blockchain restrict access to approved users. Different applications demand different access models. Fourth one is meeting specific scalability requirement for high volume transactions environments. Applications with high transactions volume need blockchain that can process transactions faster and more efficiently. Fifth is compliance with various regulatory constraints and local legal frameworks. Different countries follow different laws related to data protection and digital transactions. So blockchains must be designed to meet these legal frameworks. Because of all these factors, blockchain is classified into different types. The first one is public blockchain, second one is private blockchain, third is consortium blockchain, and fourth is hybrid blockchain. In this presentation, our main focus is on public blockchain. A public blockchain is an open and centralized digital ledger where anyone can join the network without permission. All participants can view transactions, verify data, and contribute to the system, making it highly transparent and secure. Since there is no central authority, trust is maintained through consensus mechanism and cryptographic techniques rather than intermediaries. Public blockchains are decentralized digital networks where anyone can participate, validate transactions, and access data transparently. The learning path begins with understanding the essence of public networks, which operate without a central authority and rely on distributed consensus to maintain trust and security. Next are the core technical principles including cryptography, consensus mechanism like proof of work or proof of stake, peer-to-peer networking, and smart contracts that automate processes. The life cycle of transactions explain how a request is created, verified by network nodes, grouped into blocks, and permanently recorded on the blockchain. A comparison of major platforms such as Bitcoin, Ethereum, and others highlights the difference in speed, scalability, functionality, and use cases. Real-world applications include digital payment, supply chain tracking, decentralized finance, DEFI, identity verification, and asset tokenization, showing how public blockchains solve transparency and trust issues across industries. Finally, strategic challenges remain important to the address. These include scalability limits, high energy consumptions, regulatory uncertainty, privacy concerns, and user adoption barriers. Understanding these aspects help learners evaluate both the opportunities and limitations of public blockchain technology and prepare them to engage with its evolving ecosystem effectively. Now, let us understand the key characteristics that define a public blockchain and make it different from the traditional centralized system. First is decentralization, which means no single authority controls a network. Instead, control is distributed among many nodes, computers, which increases reliability and reduces the risk of manipulation or failure. Second is transparency. It ensures that all transactions are recorded on a public ledger visible to anyone. These build trust as participants can independently verify activities on the network. Third is immutability. Refers to the permanent nature of blockchain records. Once a transaction is confirmed and added to a block, it cannot be easily changed or deleted, protecting data integrity. Fourth one is consensus mechanism, are the rules and processes used to validate transactions and add new blocks. Methods like proof of work and proof of stake help participants agree on the state of a blockchain without needing a central authority. Fifth one is open participation. It allows anyone with internet access to join the network, validate transactions, or interact with applications. This inclusiveness encourages innovation and prevents monopolistic control. Now, let us discuss the working of public blockchain. Step by step. A public blockchain operates through a peer-to-peer network where thousands of computers called nodes are connected globally. There is no central server or no central controlling authority. Every node maintains a copy of the blockchain ledger. When a user initiates a transaction, for example, sending cryptocurrency, that transaction is first broadcast to the entire network. At this stage, it is unconfirmed and waiting to be validated. Next comes the validation process. Transactions are grouped together into blocks and verified using consensus mechanism such as proof of work or proof of stake. This mechanism ensures that only valid transactions are added to the blockchain. Once a block is validated, it is cryptographically linked to the previous block, forming a continuous chain. This linking makes the blockchain immutable, meaning past record cannot be altered without changing all subsequent blocks, which is practically impossible. After confirmation, the updated ledger is shared across all nodes. This process ensures trust, transparency, and security even though participants may not know or trust each other. Now, let us discuss some popular public blockchains. The first one is Bitcoin, the pioneer. Bitcoin is the first and most well-known public blockchain introduced in 2008 by the creator Satoshi Nakamoto. Bitcoin was designed as a decentralized digital currency aiming to eliminate the need for bank or financial intermediaries. Its blockchain records all Bitcoin transactions transparently and securely. Bitcoin uses the proof of work consensus mechanism where miners solve complex mathematical puzzles to validate transactions and create new blocks. While this process requires significant computational power, it provides strong security against various attacks. One of Bitcoin's key strengths is its fixed supply of 21 million coins, making it resistant to inflation. This scarcity has led many people to view Bitcoin as a digital gold. Although Bitcoin's scripting capabilities are limited, its reliability, security, and decentralization have made it the foundation of the entire block ecosystem. Next one is Ethereum. The Ethereum smart contract revolution. Ethereum took blockchain technology a major step forward by introducing smart contracts. Unlike Bitcoin, Ethereum is not just a digital currency platform, it is a programmable blockchain. Smart contracts are self-executing agreements where the terms are written directly into code. These contracts automatically execute when predefined conditions are met, without the need for intermediaries. This innovation opened the door to decentralized application or DApps. Ethereum supports a wide range of applications including decentralized finance, DeFi platforms, NFT marketplace, and blockchain-based game. Originally, based on proof of work, Ethereum has now transitioned to proof of stake, significantly reducing energy consumptions and improving scalability. Ethereum flexibility and large developer community have made it one of the most influential public blockchain in this world. Beyond Bitcoin and Ethereum, several other public blockchains address specific challenges like the scalability, speed, and interoperability. Cardano focus on academic research and formal verification, aiming for high security and sustainability. Solana is known for its extremely high transaction speed and low fees, making it suitable for real-time applications. Polkadot enables interoperability allowing multiple blockchains to communicate and share data securely. Binance Smart Chain offers faster transactions and lower fees while support Ethereum-compatible smart contracts. Each of these platforms contributes uniquely to the blockchain ecosystem, providing that the public blockchain are not one-size-fits-all the solutions. In this, we are looking at the major use cases of public blockchains, which clearly show why this technology is gaining global importance beyond just cryptocurrency. The first use case is cryptocurrency transactions. Public blockchains like Bitcoin and Ethereum enable people to send and receive digital money directly without the involvement of banks or financial intermediaries. These transactions are secure, transparent, and can be performed across borders with a lower cost and faster settlement compared to traditional banking system. Next is decentralized finance or DEFI. DEFI applications run on public blockchains and allow the users to access financial services such as lending, borrowing, trading, and earning interest without relying on banks. Smart contracts automate these services, making them more transparent and accessible to anyone with an internet connection. The third use case is non-fungible tokens or NFTs. NFTs represents unique digital assets such as artwork, music, videos, or collectibles. Public blockchains provide proof of ownership and authenticity, which is especially valuable in the digital world where copying is easy. Another important use case is supply chain management. Public blockchain help track products from manufacturing to delivery. Every step is recorded permanently, improving transparency, reducing fraud, and increasing trust among suppliers, manufacturers, and consumers. We also have voting system. Blockchain-based voting can ensure transparency, prevent tampering, and building trust in election processes by creating a secure and verifiable voting record. Finally, identity verification. Public blockchains enable secure digital identities where individual controls their own data, reducing identity theft and dependence on the centralized authorities. Together, these use cases demonstrate how public blockchains are transforming multiple industries. This explains the security mechanism used in public blockchain, which make them highly reliable and tamper resistant. The first point is cryptographic hashing. In a public blockchain, every block contains a unique hash generated from its data. Next is the public-private key mechanism. Every user has a public key and which acts like an address and a private key which acts like a password. The third feature is digital signature. Digital signatures verify that a transaction was created by the legitimate sender and has not been altered during the transmission. Another important aspect is the immutability of data. Once information is recorded on the blockchain and confirmed, it cannot be changed, altered, or deleted. This makes the public blockchain a permanent and reliable record. Finally, public blockchains are resistant to attack, including 51% attack. To control the network, an attacker would need more than half of the total computing power, which is extremely difficult and costly in among various large networks. Now, let us discuss the concept of fork in public blockchains, which plays an important role in the evolution of blockchain networks. First one is, what is fork? A fork occurs when there is a change in the blockchain protocol that causes the network to split into different paths. From that point onward, each path follows its own set of rules. There are two main types of forks. First one is fork, soft fork, and last one is hard fork. A soft fork is backward compatible, meaning that nodes running the older version of the software can still recognize and accept new blocks. It is usually a minor upgrade. A hard fork, on the other hand, is not backward compatible. Nodes must upgrade to the new version or they will continue on a separate blockchain. This often results in a permanent split. Now, why do forks happen? Forks usually occur due to protocol upgrades such as improving scalability, security, or performance. They can also happen because of community disagreements on how the blockchain should evolve. Some famous examples include Bitcoin splitting into Bitcoin and Bitcoin Cash and Ethereum splitting into Ethereum and Ethereum Classic. Forks highlights the decentralized and democratic nature of public blockchains. Now, let us understand governance in public blockchain, which is very different from governance in the traditional organizations. In public blockchains, there is no CEO No central authority, no governing board. Instead of decisions being taken by a small number of group of people, control is distributed among the network participants. This is one of the core idea behind the decentralization. Governance in public blockchain mainly happens through two models: on-chain governance and off-chain governance. In on-chain governance, rules and decisions are written directly into the blockchain code. Stakeholders such as token holders or validators can vote on proposed changes. The outcome of these votes is automatically enforced by the protocol itself. This method increases transparency and ensures that decisions are recorded permanently. Off-chain governance, on the other hand, involves discussions outside the blockchain. These discussions take place on developer forums, community meetings, social media platforms, and improved proposal documents. Once consensus is reached, the agreed changes are implemented through the software updates. An important part of governance is the role of developer, miner, or validators and users. Developers propose and write code changes. Miners or validators enforce the rule by validating transactions, and users decide which version of the blockchain they trust and use. This structure allows for community-driven evolution where the blockchain grows and improves based on collective agreement rather than the decentralized control. Thank you for your time and attention.